Hello, today we are going to fix device that I was using before purchasing the Ember Mug heated cup. This is a USB plug-in heater. You put your cup here, it warm up and keep your beverage hot. Anything, it can be tea, it can be coffee. Some of them had a peltier inside and you have a switch that allow you to reverse, but they were pretty bad because the peltier have a very significant power loss, so that was like a joke. But this is only heater and it was working quite nice when of course it was operational. A lot of people have got them and a lot of people tell you that they are terrible, and the problem is most likely with the user, because if you've got a cup like this is a pretty basic cup, you are going to touch it like that, or cup like this, basic cup, it sits nicely. And you are going to see that it does not work, it's barely do anything. And the problem is that the bottom of the cup is elevated from the side, from the rim. I'm not sure if you can nicely see this. And you are basically have a very small energy transfer from the plate to the cup. So many of the bad reviews came from people like, here you can barely see this, but there is a like an inside lip that is breaking that connection and it's not going to be working properly. No heat transfer means that it's going to perform very poor. So if you buy like this device, you see that it's not working good, not warming up like it should, because it's going to pump around 7.5 watt of power, and it should keep your tea warm. Then first check your bottom. I've got the best results with a metal mug that have a very flat with a good contact. So let's see what's happening when I'm going to plug it. So I've got it connected to the power bank and nothing is happening. That's the problem. It's on. I go it to the off. Nothing happened. I go back to on. Nothing happening. Nothing on the display. It's completely dead. And let's try to open it and see what's inside. And we are good to open the unit. And as we can see, there is almost nothing. We've got the USB cable. We go through the switch into our heating element. We've got a metal plate that I've got weird feeling is going to be a bimetallic that's going to regulate the temp. We've got ceramic element, most likely like a resistor. The wire is going to be inside that. We've got some foam for the insulation because we don't want to melt the plastic piece. And yeah, I've got feeling that that's going to be a bimetallic strip and it's going to click. And that's basically everything. This is quite interesting because, to be honest, that looks like a top of a paint can. It have a very similar shape to the can that you put on top. Let's try to... We've got the article number. We can try to Google that. But this is very interesting. Looks like they use some garbage. I hope it's not not a toxic something. But as you can see, very good idea to recycle. And let's try to measure it. I'm on the continuity meter and we are on, and we've got absolutely nothing. We can check the other pair. We've got nothing, but that's how it should be. Let's click the other pair and we've got connection. On that one we do not have. So clearly the problem is in the switch. I'm going to try to find a replacement. Looks like I've got the candidate. That is a pretty close match to me. It's going to be looking beautiful. That's going to be a beautiful job. We've got it. We've got a very nice soldering job. Let's try to route the wire. At the moment of truth, I'm plugging in, and can we see something? No, we don't, but that's because I'm switch off. I go on and you can see that it's working nicely and it's warming up. Let's see how much current do we've got. 1 and 1.3 amp. I found something interesting. As you can see, I've got my clamp meter on the one wire. I'm on the DC. I'm going to zero it. I'm unplugged. I plug in. We've got 1.3 amp, 1.4 amp, and watch what's going on, because something interesting is going to be happening that I was not aware. As you can see, the current is going down, and I can tell you right now that the voltage on the power bank is exactly the same, 5.1 volt. Looks like I was completely wrong, and this is actually a PTC element that is self-regulating. This is quite an amazing device for the price. Let's see the voltage. If I'm going to be corrected, we should read a steady 5 volt. And looks like I'm correct, because we've got 5.1 volts. It kicks in because we can see how the voltage drop. That was not a fluke from me moving. That's from the device regulating itself. And as you can see or feel, we've got a good fix just by swapping that broken switch. Device is fully operational. It's looking quite nice. And we find a quite interesting thing about first being a PTC self-regulating, and the second one they reuse the can top. So thank you very much for watching. I hope you find it interesting. See you next time and bye bye.